Regular table salt is sodium chloride. You may be familiar with the fact that sodium chloride is in fact a giant 3D ionic lattice of alternating sodium and chloride ions. You may also know some properties of sodium chloride. Sodium chloride is hard and brittle and can conduct electricity when molten or dissolved in water. In this lesson, we will learn about how salt can be obtained from the earth. There are three main methods to extract salt: evaporation of seawater, salt mining, and solution in water. If you have been to the seaside and tasted seawater when swimming, you will note that it has a very salty taste. This salty taste is primarily due to the presence of sodium chloride. Seawater can be brought into shallow basins and evaporated to leave behind white mounds of sodium chloride crystals. This needs to be done a few times to get nearly pure sodium chloride. These areas where seawater is evaporated are called salt evaporation ponds. Sometimes this is done on a smaller scale in shallow metal pans called salt pans. This extraction method is usually done in hotter climates. In cooler climates, seawater can be brought indoors and boiled so that most of the water evaporates, leaving behind mostly sodium chloride. Of course, the sodium chloride left behind is not 100% pure. It still needs to be refined industrially to remove as many impurities as possible. A crucial step in the refinery process is iodization, or the addition of iodide ions. This iodized salt is important for our health because iodine deficiency can lead to enlargement of the thyroid glands, forming a goiter. Salt can also be mined in the same way that coal is mined. This is done by heavy machinery breaking away large chunks of rock salt from underground salt deposits. The rock salt obtained from mining is not usually used for consumption, but rather to de-ice roads and pavements in colder climates right before a snowstorm. This is usually a mixture of sodium chloride and calcium chloride. These salts work together to lower the freezing point of water, so snow does not freeze when it touches the roads and pavements. Another method to mine salt is to pump water into these underground salt deposits. As you may already know, sodium chloride is soluble in water. The salt dissolves in water to form a concentrated salty solution, which is then pumped back up to the surface and purified on an industrial scale. Although this process is a lot safer for humans as miners need not be sent underground, there is a significant drawback. When these underground salt deposits are fully dissolved in water and removed, this leaves behind many large caves. Can you think about what could happen in such a case? Pause, think, and continue when ready. The layer of earth right above ground can collapse into the formed caves resulting from solution mining. So what happens here is that the above-ground habitats, roads, and buildings could be destroyed. This could also severely impact the lives of those living right above or near these mining sites. This phenomenon is known as subsidence. Sodium chloride, being one of the world's most common substances, is extracted from the earth on a massive scale. However, we must still consider the environment and the consequences of these mass extraction processes. In summary, there are three main methods to extract sodium chloride on an industrial scale: evaporation of seawater, salt mining, and solution in water.